Okay, so let's just jump right in because something absolutely mind-blowing just happened at the intersection of AI and mathematics. For the very first time, an AI has entered the arena with the world's most brilliant young mathematicians, and it actually won a medal. So check this out. These are the results from the 2024 International Mathematical Olympiad, the IMO. This is basically the world championship for high school math geniuses. The AI system, which runs on an engine called AlphaProof, scored a 28. Now you can see the silver medal cutoff was 22. It didn't just scrape by, it blew past it. And get this, it was just one single point away from a gold medal. 1 point.
I mean, let's be super clear here. We are in completely new territory. Until now, the best AIs could maybe solve a couple of the easiest problems from old competitions. Winning a medal at a live event, that was pure science fiction. This is a massive milestone.
And that brings us to the real question, right? How does this even happen? IMO problems aren't about crunching numbers. They demand serious creativity, these leaps of insight. So how on earth can a machine develop the kind of deep reasoning it takes to solve problems that stump the smartest kids on the planet? Well, that's exactly what we're going to break down. It turns out the answer starts with a totally different way for an AI to think. AlphaProof is not your typical large language model. It's playing a whole different ballgame.
You see, most AIs we interact with, they reason in natural language, kind of like we do. It feels creative, it's intuitive, but it can also make weird little mistakes, the hallucinations we hear about. Its logic isn't provably correct. AlphaProof, on the other hand, works in the world of formal reasoning. Imagine every single thought, every logical step is written in a super strict mathematical language. A computer kernel then verifies each and every one of those steps. The result? The final proof is guaranteed, literally guaranteed to be 100% correct. No mistakes, no fuzzy logic. So what even is a formal proof? The best way to think about it is like a game, but with the strictest referee you can possibly imagine, that computer kernel. It is watching every single move you make. If any step, no matter how small, breaks a rule of logic, it gets thrown out immediately. This makes sure that the entire chain of logic, from the very first assumption to the final conclusion, is completely unbreakable. Okay, so you want to build an AI that can spit out these rock-solid proofs. How do you actually train it? It's not like you can just have it read Wikipedia. You need a very specific training plan. And right out of the gate, the researchers ran into a huge problem. A massive wall, really. To get good at this, an AI needs to see millions of examples. But the number of math problems that humans have painstakingly translated into that strict formal language, it's tiny. There was nowhere near enough data to train a system like this. So what did they do? In a classic use AI to build AI move, they created a specialized AI translator. Its only job was to take about 1 million math problems written by humans in normal language and automatically convert them into 80 million formal problems. Just like that, they created their own massive custom-made training library that never existed before. The training process itself was like a 3-stage rocket launch. First, they did pre-training on a giant dataset of text and code. We're talking 300 billion tokens, just to give it a basic grasp of logic and structure. Then, stage 2, they fine-tuned it on that small set of human-written proofs to teach it the specific rules of formal math. And for the final, most powerful stage, they just unleashed it on those 80 million problems they generated, letting it learn from trial and error, getting better and better with every attempt. But here's the thing. Even with all that training, the absolute hardest IMO problems, the ones that separate the medalists from the legends, they require something more. They require a secret weapon. Just for some context, AlphaProof solved problem 6 from this year's competition. This was the monster problem, the one that only 5 human students in the entire world managed to solve. A general-purpose AI, no matter how smart, would probably just hit a wall and give up. So when the AI gets to a boss-level problem like P6, how does it prepare for that specific fight? It doesn't just rely on what it already knows. It actually stops and trains itself all over again, specifically for the challenge right in front of it. This technique is called test-time reinforcement learning, and it is just brilliant. When the AI sees a really hard problem, it doesn't just charge in. Instead, it pauses and generates hundreds of thousands of simpler, related side quest problems. It basically creates its own custom study guide on the spot. Then it runs a quick, super focused training session on those new problems to level up.
Only then does it go back to the original hard problem, now armed with brand new insights and strategies, and cracks it. This is obviously a game changer for competition math. But the real story here, the really exciting part, goes way beyond the Olympiad. So let's zoom out and talk about what this breakthrough actually means for all of us. And wow, just look at the performance jump here. It's staggering. On other tough math benchmarks, like historical IMO problems or the Putnam competition for university students, which is notoriously difficult, AlphaProof isn't just a little bit better, it's a quantum leap. It's solving over 10 times more Putnam problems than the previous state-of-the-art system. This isn't just an improvement, it's a completely different level of performance.
So why should you care? Well, for one, this is a huge step toward AIs whose reasoning we can actually trust. 100%. That could be a revolutionary new tool for science, helping researchers check their work on incredibly complex proofs, or even helping them explore completely new scientific ideas. What this really points to is a future of deep collaboration between humans and AI, where these systems act as incredibly powerful partners for our best researchers.
The research team behind this said it perfectly. They said that by learning from grounded experience, that's the key phrase, meaning every step is checked for correctness, they've built a system with truly complex reasoning, and this paves the way for a reliable AI tool to solve the hardest problems out there. And that kind of leaves us with one last really exciting thought. For all of human history, the edge of science has been limited by what our brains can handle, the complexity we can juggle. But if we now have a tool that is guaranteed to reason correctly, a tool that can do it at a scale we can't even imagine, what new questions, what once impossible challenges can we finally dare to take on?